Cathode Muon Detector Array, or the CMDA. It is made up of 8 scintillating bars. Each bar has photomultiplier tubes connected to either end in order to detect the light that is created when a muon comes into contact with the bar. These bars are identical to the ones found in Mona and Lisa, however Mona and Lisa is a greater array. The idea of this experiment was to determine a spot in space where muons were coming from. Muons are members of the lepton family, which are created when cosmic ray particles collide with nuclei in our upper atmosphere. Muons easily travel through people and walls, so they are not obstructed by the walls or ceilings within this lab. So, in order to create this sky map to determine where the muons are coming from in the sky, a muon will travel down, it will hit one of these bars, and it will create a light within the bar. The light will travel to the photomultiplying tubes on either side. By knowing the time it takes for that light to travel to the photomultiplier tube, we can determine the position that this muon hit the bar. As you'll notice, there are also 2 levels of bars to the array. This is so we can create 2 points in space at which these muons are hitting, so that we can map an angle at which these muons are coming in on. The CMDA is also oriented in a certain geometry to space. This is so that once we find the angle at which the muons are coming in at, we can map that to a place in space. Over time, we will be able to create a spot where these muons are coming from, and hopefully we can connect that to another celestial object such as the sun, a black hole, or deep space. When I began working in the lab, the CMDA was completely out of service. There was hardly any programs used to created to collect the data from it, and the ones that were created routinely crashed and did not collect the data properly. I re-established the CMDA by reworking these programs in order to begin collecting data off of the CMDA. I determined and oriented the CMDA to a specific geometry in space so that we could create this sky map. I checked it for light leaks to make sure that all of the events that were coming in were completely valid, and I also created the appropriate logic units to determine that we were only getting valid events. When I mean valid events, I mean a muon is hitting a top bar as well as a bottom bar, and that's just to make sure we're not getting light pollution or a scattering off the wall. We want clean events coming directly from sky into the bars. In order to do this, I connected the photomultiplier tubes to the logic units that you will see over here. Within these logic units, I then created parameters that said an event was only valid if a muon hit a top bar and a bottom bar. This would then work into my program where I was collecting data, and then I eventually began creating this sky map. Thank you so much for taking the time to watch my video and listen to the amazing things that are happening within nuclear physics at Westmont College. I hope you enjoyed it and learned a little bit more about nuclear physics. Thank you.